What's up, everybody? It's your boy Alejandro here, bringing you those sick Maya rigging hacks that you absolutely need in your life. So grab your energy drinks, cause today we're diving into the rad world of spinning tires using nothing but the power of Maya nodes in Maya, baby. I'm gonna assume that you already know how to use Maya because we're not messing around with the basics here. Check this out. I've got this dope ass tire I whipped not too long ago. We got a joint, we got controllers, we got the gear to make this baby move. We got the main controller for that sweet forward motion. Another for steering, cause you gotta steer the course, am I right? And one more for precision and scale, cause it's all about control, baby. And pip this, I've centered those pivots like a boss, so everything snaps to the tire center like magic. But hold up, this tire, it ain't got no game yet. Moves in Z, sure, but no spin? Nah fam, we gotta fix that. Stat! First up, we gotta crack the code for the tire circumference. It's all about that C equals 2 pi r action. You feeling me? Let's snag that radius, and I'm gonna show you how with a distance node, cause we're tech savvy like that. So the radius is like the heart of the circumference, you know what I'm saying? From the center to the edge. So I got here the first locator for the distance node chilling right here at the origin of the world. That is 0, 0, 0, 0, 0, 0. You know why? Because it matches perfectly well with the edge of the tire. Right side view. Zoom in. Zoom, zoom, zoom. You see? Yeah, well, it's a little offset, but you know what? It's such a small difference that it doesn't really matter. Now, for the second locator for the distance node, it is right in the middle of the tire. Look at it. Beautiful. And just to show you guys that I'm not lying, that it matches with the first locator, check it out. We got translation X at 0 and translation Z at 0 as well. We are just using the translate Y to create the distance that we need right here. As a result, we have this beautiful distance node telling us that the distance between locator 1 and locator 2 is exactly 8.34. And that's perfect. This is going to be our radius that we're going to use for the circumference. Now, let's parent this bad boy under the world control. It's gonna make our radius flex when we scale, adding an extra layer of cool. Stick with me, I'll break it down more as we go. Alright, now is node editor time. Now, if yours is cluttered, then do some clean house, alright baby? Because we need it to be nice and clean. And let's just tuck it here to the side so we can see it better. And squish this a little bit more because I want this tire to be nice and sexy all the time. As promised, we are calculating the circumference of the entire tire. Ha ha ha, that kinda rhymes, doesn't it? So, well, the first thing that we need to do is we're going to calculate pi times 2. You know what I'm saying? So here, right here, you click over here in the node editor and then you go tap and then look for float math. Look at it, nice and simple. Now, some of you folks might like to use things like multiply, divide. But you know what? I don't like it. Look at it. It's got 6 channels and I feel that 4 of them are irrelevant. I don't need it. And not only that, look, it only got 3. It's only got 3 functions. Nah fam, screw that. So let's get rid of this node right here. Click on float math again and set it to all these beautiful operations right here. Don't you just love it when you have all this power? Anyway, so like we said, we're doing pi times 2. Therefore, set it to multiply. Boom. And now for float b, we're going to set it to 2. And the first one is going to be set to the value of pi. How do we do that? It's easy. So bring out this command editor with a new fresh Python. In case you don't know, just go over here, hold right click and go new tab, Python. Now this cool thing about Python is the following, that we're going to import this thing called math. Not math, math with an A. Look at it. And then we hold control and scroll up to make the text bigger. We go down 2 lines, and then we're going to do the following command line. Print, left bracket, math, because we need to use math, period, pi. That is pi, pi. Close it with the right bracket, select everything, and then just go numpad, enter key. Boom. And then we also make this text bigger, so you can see I ain't lying to you. Look, scroll down all the way down. Here it is, the value of pi, baby. Boom, let's copy this again. Minimize, and set it here. Let's go back to the float mat. And we paste it. Woo! Now, really important, Riggers, really important. You know how it goes. You just know how it goes. You just gotta rename your stuff. Because why? Because why? Because you're a pro, that's why. So look, this is going to be called pi multiplied underscore fm for floatmat underscore 01 in case we need to make more. Oh, and really important, let's not forget, in case you haven't done this already, make sure that here the operation style is set to multiply, baby. That way we're going to multiply the value of pi by 2, giving us the first part of the equation of 2 pi. Alright, now that we got that going, let's grab the node again, hit Ctrl D to duplicate it, and we're going to rename it to something extremely cool. You guys ready for this? Let's delete pi multiplied and type circumference. Now these things are really contracted, you know? Let's expand it a little bit. So just click over here in the empty space, tune, and then just hit 3 on your keyboard. Wham! Expand it. Yeah, baby. So how are we going to get the circumference? It's quite simple. We are going to get the out float of the first math node and plug it directly into float A. Yeah. So if you click on it, you see you got this value right here, and it's exactly the value of 2 pi. Now, in order to get the radius of this beautiful tie right here, you already know what to do. You go over here to the radius distance node, you click it, and then you add it to the node editor. Now we do not need the transformation node, so we can get rid of it. Note, do not delete it, just remove it using this button right here. Boom. Now you click on this distance node shape and you hit 3 to fully expand it. And we're going to use the distance attribute directly under float B for circumference FM. Click it, and then you see you got the 2 values nice and yellow, meaning that they are connected. And of course, the formula requires that you multiply 2 pi times the radius of the circle, and that is exactly what we're doing over here. Yes, you can see we're still in multiplies. Yeah, baby, so we got everything working good so far. So now that we got the circumference, we are going to grab any of the 2 math nodes and duplicate them. Just one. And this is going to be different than the other 2 because we need to divide, baby. You know about dividing? Well, I do. Check it out. You go over here to operations and set it to divide. Why? Because we're going to use the value of the circumference to divide the value of the translation of this control right here. And I'll show you just how to do it. So expand this node over here. Oh, really important. Let's not forget, delete this and then rename it to something cool, something that makes us understand that what is this going to do. Spin divide. So here the order of the operation is really important. We need the circumference value to come after because it is going to be on the bottom part of the division. And now that we have that going, here we're going to go over here into your main viewport scene, grab the forward controller of your tire and import it into your node editor like this. Wham! Since we're working with the transformation value, we do not need the shape node, so we can get rid of that and just expand the transformation node. Double check which of the 3 translate are you using. In my case, look, I'm using translate Z, but if you're Canadian, it's called translate Z. Alright, now let's bring translate Z into the house, directly to float A for spin divide. Woo! Here's the deal. Circle rolls 1 full turn, covers distance equals to its circumference. Circumference is 100 units, moves 100 units, that's a full 360 spin, for example. In my case, check it out. We click over here into the circumference value, 52 units. We copy this value. Now we grab the forward control in our tire and we paste that value directly into it. Look at it. Wham. Now, I want to show you what just happened now that we moved the forward control the same amount of units as the circumference of the circle. So we grab the spin divide node, duplicate it because right now we don't care too much about it, and we're going to connect the out float into any of the two channels so you can see what the out value is. It's a total of 1. And you see, this doesn't work a lot because if you only rotate the wheel by 1 degree, you don't get a lot of motion. So instead, we're going to repurpose this math node right here. So first thing is first, we rename it. Delete this 2, put it to 1. Instead of calling it divide, we're just going to name it something that makes sense, such as spin 2 degree. And now we need this to be a multiplier. So let's go back into operation, set from divide back into multiply. And now for the second channel, what do we need? If you're smart enough, you already know what we need to do, buddy. That's right, we need to set it to 360. Why? Because a full rotation has 360 degrees. Our setup is complete actually. This can actually be connected directly into the joint that already moves the tire. Oh, you cannot see it? Here, let me show you. Make X-ray. Here, the joint right in the middle of the tire. We are going to grab the joint, but in my case, I'm going to grab the group that is above the joint. So I'm going to go up on my keyboard, and here on my outline, you can see there is a group over here that I made specifically so that it can absorb the output of this last math node right here. So let's put it inside the node editor like that. Move it over here, expand it, and since we are rotating on the x-axis, look at it. The arrow is perpendicular to the cylinder of the tire. So we're going to expand the rotate attribute in this transformation node. And real quick, to make sure that your things do not bounce around in the node editor, just hit P on your keyboard to pin them all. With that, we are going to connect the outflow of the spin to degree float mat directly into rotate X of the joint, of the joints group. Like that. As you can see, it created a, well, it moved all the way over here. That's why I like to pin my nodes in the node editor. It made a unit conversion node right here. Don't worry about it. Maya just does that. It just needs to do that. So anyway, now that we have this thing fully hooked up, let's see if it works. So you grab the forward controller and you move it forward, and look at this. Look at this beauty right here. Look at it, moving precisely. Instant feedback. No funny business, no monkey business, just exactly what you needed to do. And to show you that I'm not lying, check it out. Let's go into right side view. Maya, right side view, right here. Let's undo this real quick. Like that. And now check it out. Making sure that we're translating in the z-axis using the forward control that I created. Let's zoom in real close to the edge of the wheel and see it like this. Look. The little teeth are sticking to the floor like real wheels do in real life. Lovely. Now, if you want to, maybe you want to end it right here. Call it a day, you know. Drop the mic here. But you know what? This setup has scaling. Maybe, just maybe, you want to scale your rig too, you know. But there's a problem. There's a problem with this setup right now. Let me show you right now. Real quick. Now this thing right here, this attribute that you see called size, it does exactly what you think it does. It scales the thing up and down. Let me show you. That thing, I do it for myself. I like it. Feels good, you know? Thing is, you don't have to do it. You can just skip it to just having the 3 scale attributes and call it a day. Now, we have to do the extra steps to make sure that when this thing becomes bigger or smaller, you want to make sure that the function is retained. So here, real quick, let's make it bigger. Now, will it work? There's only one way to find out. So we grab it and we move it in. Oh no, it doesn't work anymore. It is sliding. Look at this disgusting thing, brother. Ugh, brother, ugh. What's this, brother? Look. Here on the right side view, look at how ugly it is. Look at that disgusting sliding. No! All the hard work, all thrown to the garbage. Or is it? Now you might be asking yourself, why is this happening? And I can tell you why exactly. It is this controller itself, and the fact that it is outputting this value right here. The thing is, this controller doesn't know that it became bigger. If I set this back to size of 1, the value remains the same. Look at it, 1.16. And that's not good, because that means that the controller that makes the tire spin is not updating with the rest of the world. Let's make it big again. This controller needs to output a different amount. It's still 1.16, and that's no bueno. So to give you an example, let's say create a locator right here, just random, just like that, and then we align it to the controller itself, and then you select the locator. You can see it right here on the Z value, 3.6. That's how much this controller right here needs to be in order to give us that beautiful rotating motion that we worked for. The way we are going to go about facing this issue with the mismatch between the size of the tire itself and the forward momentum of this controller, the forward control, is quite simple. We are going to multiply the value of the size attribute, which is this one, 3.1, by the forward translation in Z of the forward control. And in order to do that, we grab any of the math nodes, anyone, and duplicate it like how we usually roll. And we're going to simply rename it scale fix underscore fn underscore 01. Make sure it is set to multiply so that we save ourselves the headaches. Multiply like that. So as promised, we grab the size value, plug it into the float B. It could be float 8 anyway, it's a multiplication after all. And then we grab the translate Z of the forward control directly into the other channel. Boom. And for the last bit of magic, we connect the outflow directly into where the translate Z connection was. So float A, like that. And now we test it out. Did it work? Look! Look at it! It's working again! Woo! Woo! Look, to show you that I'm not lying, let's go back to the right side view. We make sure that we grab the forward controller that is going to be translated into translate Z, and then we just scroll with the middle mouse button like this. Look at it! Look at this beauty right here. It is doing it. The little teeth are sticking to the floor like it should. And to prove to you that I'm not lying, I'm going to grab here this blue line, which is the world controller, again, and set its attribute to something else. Say, and then we zoom in a little bit more. As you can see, the radius also changed, like I intended it to do. And we grab it again, and we move it, and look at it, it's still doing its thing, even though the scale is different. And again, grab the world control, set the size to something crazy like 25. Look at how big it got. It's crazy, bro. Look at how big, look at it. Look at how big the radius is. But that's not important right now. What's important is that this thing, it works. Look at it. It's working. It's working. Oh, yeah. Now, let's be honest real quick right now. That this setup right now, it is not the be-all and end-all. It can be improved. It can be made better. Because right now, say that you just want to make this thing go forward and you also want it to steer like they normally do. Right now, I can only do it by grabbing this controller and rotating it, making sure that we use this controller to make it go forward. And then we use the world controller to position it, and that's about it. As you can see, that might be cumbersome for your animators, and I respect them, because they need things to work, you know? They need to work. Those are the cons. The pros is, like I mentioned before, it is precise, it works, and it's instant feedback, and you don't need an expression like they usually do in 3D studios to make it work. Thank you for watching.